And I think with that, we're back to you, Martha, for our next speaker.
Great, thank you very much, and thanks for the technical explanations. Now it's a pleasure to welcome Franz Forsberg. He is CEO and Sustainable Environmental Design Specialist. It is a company that he's formed in Norway called Data Trees. And when I queried him, he said it's not about wood, but it is about trees, the organization of complex data. And what he does is delivers software to help architects make more sense of the world and to facilitate for the whole AEC industry a way towards more sustainable and performative architecture. Franz, the floor is yours. Welcome.
Hello, everyone. Thank you for having me here today. My name is Franz Forsberg, and I'm co-founder of Data Trees. And I'm here to discuss how we are working to democratize the access to high-fidelity, design process integrated daylight simulations in the IC through Open BIM and the web. Briefly about us first, as a short introduction. I'm an architect specialized in sustainable environmental design, and my focus is to reduce the gap between architects and engineers. And as co-founders, we also have André Agui, an incredible architect who focus on leveraging the complex decision-making through algorithm and graphics. And we also have Stian Hagrim, which is an incredible BIM expert and system architect who connects buildings to technologies. What we do is we say, architectural knowledge into algorithm by encoding architects and engineers' expertise into powerful digital applications to leverage their intuition in all design phases. Our vision is to facilitate the way toward a more sustainable and performative architecture. Using the massive amount of data in the world around us, we deliver tools and interfaces in order to inform and communicate the performances of the design. So now, let's say how we work in democratizing high-fidelity daylight simulation through Open BIM and the web. Why is that important? Let me tell you about a raising concern I see our industry is facing. The awareness on the important role of daylight in indoor occupancy is growing from multiple fields, leading to better defined building codes or regulations, but also green label requirements and standards and recommendations. In Scandinavia, we are imposed by our building code to provide satisfactory daylight conditions in our buildings and our regularly occupied rooms. And the Norwegian, the Danish, and the Swedish building codes, they differ in the methods for compliance, varying from simple window to floor area ratio to daylight factors or to climate-based daylight simulations. In architectural projects, stakeholders such as architects, engineering consultants, developers, public authorities, each have their own opportunities and challenges regarding daylight. In Norway, architects have the legal responsibility to provide proper daylight conditions in their design, but they often lack the knowledge in how to do those assessments. Therefore, consultants, engineer may be delegated the task, but their workflow are often incompatible with the design process of the architects. The developer is often the most concerned about the delivered customer value in their product, in their buildings, although they have a controlled budget. And municipalities, public authority have to deliver building permits, but they often like the way to do those procedures, those control procedures. I've done some research in my closed network to understand the practices or perhaps the struggles in daylight assessments. And here are some findings. In Norway, almost half of the permit assessors in municipalities, In Norway, almost half of the building permit assessors who look at daylight in projects do not know if daylight factors is a proper indicator for good daylight. And as many daylight simulation practitioners, architects or engineers believe it is, and as many do not. Furthermore, 80% of them have never done climate-based simulations. Reasons are sure multiple. Some claim it is the lack of appropriate software. Finally, daylight consultants spend on model conversion and remodeling, often between 20 to 50% of the total consulting time, assessment time, and very often close to 50% or above. Daylight simulations are therefore often left aside, often due to poor simulation practices from the architects or workflow incompatible assessment evaluation methods from the engineers, economical restraint from the developer, or post-design evaluation difficulties from the municipalities. When daylight is assessed, it's not always performed in the state of the art. Daylight simulation practitioners are not always educated in daylight. They are often coming from an energy consulting background, leading to various methods where elementary rules are often forgotten. Understanding and use of climate-based daylight metrics also diverge greatly, as we saw previously. Leading consultants do not always have a clear understanding of the daylight conditions, their yearly variations, seasonally and daily variations. We see, therefore, compliance chasing being the standard practice, where daylight is only assessed to tick a box. The research and the academic world, as well as better defined standards, are providing us with valuable methodologies. However, there is a great potential in improving and applying good daylight in designs. Verb, democratize, makes something accessible to everyone. Something, we are talking about the access to high-fidelity daylight simulation. And everyone, by making the data work more, the consultant perhaps work less, for more projects to be assessed. It's also important to involve the designers and also other decision makers. And to achieve this, to democratize, we may need the help of the wisdom pyramid, as I call it. What does a daylight consultant do? In a nutshell, a consultant provides expert opinion, analysis, recommendations to organizations or individuals, based on their own expertise. They provide strategies to prevent problems and to improve performances. So an interesting question we had at Data Trees with my two partners is, can a consultant be replaced by machine learning to help democratizing? Could I, the consultant, delegate to Albert, it's our mascot, who supports building design? Could I delegate the task of providing expert opinions, analysis, recommendations? To succeed, we will have to teach Albert how to climb the pyramid. And perhaps I should say aided by, to be a little bit less controversial. First step is the data step. Collect and create data. Albert needs a lot of data to build its own experience. We can collect valuable data from the architect's BIM model, some metadata, but also, and most importantly, geometrical information. Then we simply need to perform annual climate-based daylight simulation. Albert could then, as a second step, present the data to convey facts using the various climate-based daylight metrics to tell us about daylight availability in space, in time, glare potential, the uniformity of daylight, sunlight, glare potential. Oops. Albert lives in the cloud, so we will use the web as a device-neutral platform, the web browser, since it's accessible by everyone. We need now to teach Albert to contextualize the information, to give a practical understanding. It's important for designers and everyone to quickly be able to grasp if a room complies with a specific requirement. It's important to rationalize the metrics to a simple yes and no answer. Albert can now give knowledge in a simple and clear manner. Sometimes the question may be more subtle, and we may need a little bit more of details. And you would like to know, for example, if an east-facing room is receiving enough daylight in the morning or in winter. Therefore, it's important to go beyond the standards and to dive a little bit into research for inspiration. Here is a research paper I really enjoy by Timur Dogan and other students from the Cornell University who are trying to complement our understanding in how to assess daylight. There are many, many more. It's absolutely valuable that the research and the industry stay aware of each other to together always help us deliver better methods. Thank you for all of you who are in the research and the academic world for lifting up our industry. Finally, wisdom. It's about making a sensible judgment. And how could Albert possibly make a sensible judgment? If we train our data and cluster various room-level recommendations with machine learning, Albert could do the heavy lifting of the consultancy. Of course, it's important for the teachers or us, the daylight experts, to always revise and perhaps complement the recommendations. It's also very important to involve the users and to allow designers and all other decision makers, disciplines, to comment, validate the assumptions. We saw that research, regulations, and recommendations progress. There is therefore a need for spreading the advancement and better understanding daylight in our industry. And as more projects are being built or reformed, there is an increasing need for design-integrated, reliable evaluation workflow. We need a tool for a collaborative decision-making, a tool which for greater user value has to be convenient, fast, and reliable. Here is a short preview of our first attempt to amplify the architects and the engineer collaboration, where project information is displayed, rationalized, pass or fail, green or red information towards specific benchmarks, such as the local requirement or a green label, such as BREEAM or WELL, or point values are displayed in a 3D model. So how do we create that? For the user, an architect, a designer, a BREEAM assessor, a municipality employee, which is looking to verify a project's compliance, a simple IFC can be used. And our market in Scandinavia, luckily, is very BIM dependent. And architects can export IFC files. IFC classifications and IFC spaces have the required geometrical information needed for a daylight simulation. The output of the simulation could also be exported through the BCF BIM format back to the model. Focusing on the web, computing is done on the cloud. So every device, a phone, a tablet, a computer, any operating system can access the simulated model in a 3D applications, no files on your computer, and CAD-like editing is also possible. IFC to daylight model conversion can be done on the cloud, and a sharp guy can quickly estimate the validity of the model and eventually do some corrections. Performant custom algorithm can understand an architectural project and classify rooms in a residential project to understand what is a bedroom, what is a living room, a kitchen. Other algorithms can also set appropriate light and reflection values to the geometries to convert an IFC file to a daylight model. Calculation speed has greatly evolved lately with multiple cloud solutions using CPUs, GPU local solutions, or you can also create your own architecture. Data, geometries, and other IFC metadata can be published to an online platform directly after simulations. Raw simulation data is uploaded to a server where custom functions calculate the appropriate metrics. And the metrics result are benchmarked against a building code or a certification scheme. Well, of course, radiance is the holy grail here. What else? But of course, you have to comply with all the standards and methodologies. Reliability is also ensured by measuring various metrics and looking at them together to understand the strength and weakness of each of them. Here is an example I like, for example, of this project where this south-facing room has a daylight factor of 1.3. The north-facing room has a daylight factor of 1.9. Many consultants will unfortunately assess that this room has better daylight access, but looking at how much of the room has lux values above 100, has special daylight availability of 100, we see that the south-facing room has much more light uniformity. UDI also gives interesting information. And we also see that the southern room also have much more annual sun exposure. Your data is knowledge. We must train it properly and make it help us to draw meaningful conclusions. Have your own butler at your service. We are still working on this part, so I won't show too much here. Take the lead, create your own collaborative platform, support our industry, support research. This is only our attempt to create a platform-neutral solution. Please help us delivering the same in your industry. Thank you.